So our teacher told us we're going to do a math review today, but we're using Orosama. And he told us that the first clue could be found by using the top of this folder, and then we'd learn more about it. So let's see what happens.
Operatives. We recently intercepted a large data transmission from a rogue nation. We've only been able to decrypt a small portion of the information, but what we've learned is that the nation is planning on carrying out a large-scale attack here in Nashville. However, we do not know what form this attack will take. Each file of the data has been encrypted using a separate password, and the password has been sent to different teams that will be carrying out these attacks. We have been able to decrypt the first file, and what we've learned is that these attacks will take place at 12:45 p.m. today. Each team has an equation that, when solved, provides a password needed to decrypt more data. When you solve the problems, use your phone to show us the answer and we'll send you the decrypted information. You were chosen for this mission because of your mathematical prowess. Much of the information is hidden in plain sight. You'll need to use the Orosama app to find the hidden information within these pictures around the school. In addition, you'll find a notebook inside of this envelope. Please copy down each equation in your team's work showing how you solve the problems and tell headquarters a little bit about each problem. Headquarters wants to research the equations more fully and find out if there's any connection between them. This is the equation you'll need to solve in order to find the location of the next clue.
Okay, I'm going to take a picture of it so we can go back and look at this equation. So let's see what's in the top secret file. Alright, we have our secret agent notebook. What else? We have a pen. And oh, okay. He told us that the answer choices would be with each problem. So I'm guessing these are the answer choices. So let's see, team member. So Sanders. And the instructions. Let's see, we need to show all of our work to solve each problem. We need to give the answer to each problem and tell what area of mathematics it fits in. Headquarters wants to know this so they can learn more about this rogue nation. Okay, let's see. Let's flip to our first one and flip to the equation. So I'm going to open up, and I had saved this, so here it is. So the first one, all right, this looks like a quadratics problem. So the area of mathematics is quadratics. Let's see what it tells us. So it gives us the general formula, so I know I should write that down. It's in intercept form, so that's good to know. All right, see, I'll copy this graph real quick too. And it looks like they have me crossing at -2 and +4. And down here, it looks like I'm on the y-axis at -4 also. And it tells me, yeah, okay, it tells me I passed through the point -2, 0. Tells me I passed through 0, -4, and 4, 0. So that looks right. And what do we need to find? All right, we need to find the value of P up here. So P, okay. So let's see how we can do that. Well, I know Q and R because it's intercept form, so Q and R are the intercepts, so I can fill those in. So I know that Q is going to be a +2 because the -2, and I always change the sign, and I know R is going to be -4 again. It's intercept, and so I change the sign. Let's see what else. All right, I know the y-intercept, so I know that if I plug 4 into the equation, I should get an answer of 0 in there. So let's see. Nope, let me rephrase that. If I plug in a 0, I should get an answer of -4. This is why we need to make sure we read the problems well. So let's try that out. So I get negative 4 equals P times negative 8. So P would have to equal 1/2. All right, I filled out the first problem. Is 1/2 one of my answers? It is. Okay, so I don't need those two. It looks like 1/2 is one of the answers. Let's see if this is right. Let's open the Orasama app. And let's see what happens. All right, let's see. I'm going to use it. Let's turn on some more light. Okay, the picture. So that must be the next location I need to find. Let's see if we can find this picture. So I'm going to grab my notebook, I'm going to grab my pen, and we're going to go see if we can find that picture. Let's hold up and see what happens. Okay, I'm going to take a picture so we can stop the evil rat guy. See if we can solve this problem. All right, let's see. We have, what does this look like? Okay, I'm going to flip to equation 2. All right, oh, I recognize this. This is one of those area of a sector problems. So let's see, this is area of a sector. And this is part of trigonometry. Let's see. All right, I'm going to copy this over. So we have 2 circles.
It's not bright enough.
And let's see. Let's copy the problem over. Need to find the area of this shaded section. What else does it tell me? It tells me that the angle is pi over 3 radians. Let's see, it tells me this short area is length of 8 and this longer area is a length of 10. And let's see, what else do I need to know? All right, I want to find the area of this shaded region, okay? All right, how can I do that? Well, let me think. I know the equation, area of a sector, is 1/2 theta r squared. How could I use that? Okay. Let's see. If I find the area of that larger sector and I subtract the smaller sector from it, that should give me the area of the shaded section. So let's see how that goes. So let's see. We have my theta is pi over 3. And the larger section, the radius of the larger section is 10. So 10 squared. I need to subtract from that. Let's see, 1/2, and again the radius and the area, let's see, pi over 3 and 8 squared. So let's work this out. I'm going to get pi over 6 times 100 squares minus pi over 6 times 64 squared. And let's simplify this down. Now I'm going to get, let's see, 100 minus 64. That's going to be 36. And if I simplify this, I get 6 pi. So 6 pi should be the answer. That should be 6 pi units in the shaded section. And I think I saw our multiple choice options up here. Let's see if that's one of them. Let's see, 32 pi over 3. That's not it. There is a 6 pi. Let's see if we got it right and see if we can get our next clue. So let's go back to Orasama and see what we get. All right, that should be right. Oh, I got another picture. Okay, it looks like a B. Let's see if I can find this B. I'm going to leave these. I'm going to take my workbook. and see if we can find this next clue and learn more about this attack that's going to happen so we can stop it. Okay? Let's see, do we get another clue?
Nexus Computing has created the first viable quantum computer. I must have it. This computer will allow me to break any encryption. No country or organization will be able to stand against me, and I will be all powerful. I cannot overstate how important this piece of technology is for me, a country, our country, to rule the world. 3 coordinated attacks will be a diversion. It will cause so much chaos. During this chaos, another team will break in and steal my new computer. You must rendezvous with Gamma Team to learn about the attacks. To find Gamma Team, you must solve the following problem. There are 120 people. Of those, 75 speak Japanese, 35 speak Chinese, and 20 speak neither language. How many people speak both languages?
Okay. Alright, I'm going to have to listen to that one again. But I do know that's going to require a Venn diagram. Because that was a statistics problem. So let's draw that out. And they're speaking Japanese and Chinese, but I don't remember the numbers. So let's see if we can listen to this again.
Nexus Computing has created the first viable quantum computer. I must have it. This computer will allow me to break any encryption. No country or organization will be able to stand against me, and I will be all powerful. I cannot overstate how important this piece of technology is for me, a country, our country, to rule the world. 3 coordinated attacks will be a diversion. It will cause so much chaos. During this chaos, another team will break in and steal my new computer. You must rendezvous with Gamma Team to learn about the attacks. To find Gamma Team, you must solve the following problem. There are 120 people. Of those, 75 speak Japanese, 35 speak Chinese, and 20 speak neither language. How many people speak both languages?
Okay, I think I got it. So there's 120 people. 75 speak Japanese, 35 Chinese, and 20 don't speak anything. All right, let's see. We need to figure out how many speak both. All right, so if we have 120 people, then that means, and 20 of them don't speak anything, that means we have 100 people that fit in here. And of those, we know that there's 110 who speak a combination of those two. But that's more than 100, so that must mean 10 people speak both, because that must be the overlap. So 10 should be our answer. And since we need to show our work, we can finish everything out. So we have 100, 110 total. So if we subtract the original 100, that gives us 10 left over. So that means we have 65 that speak just Japanese, 25 that speak just Chinese. So let's see if 10 works. I think I saw our answers. See, 10 is one of them. Let's see if it's right. All right. Oh, we got another picture. All right, I've seen this one before too, so let's see if we can go find it. I'm gonna grab my notebook. I think this is what the next clue is.
You will each carry out coordinated attacks at 3 different locations. One team will head to Opry Hotel, the second team will head to Nissan Stadium, and the final team will set explosives throughout Percy Warner Park. You'll need to meet Epsilon Team to get the explosives. Make sure you make this happen. I will be a leader of the world. So solve this problem to find your next location.
I'm gonna take a picture of it again. All right, let's look at this problem and see if we can solve it. All right, so an arithmetic sequence. Okay, well that's the area of math that we're in. Let's write that down. Arithmetic sequences. And they tell us, okay, we know that U1, so we know our first spot is 2. They tell us that U3 is 8, so we know the third spot. And they want us to find U sub 20, so the 20th spot. All right, I know to do that U sub 20, if we start at the first spot, and we go, if we're starting at the first, then we need to go 19 more spots. And we need to increase each time by whatever the difference is. So we need to figure out that difference. So let's see. So U3, so the third spot minus the first spot gives us 6. So to go those 2 spots, we had to go 6 spots. So that means each time we're moving a distance of 3 spots. So I'll put that in. So U sub 20, our first spot is 2. We're moving 3 numbers each time, and we need to go 19 spots. So let's see, that'd be 57. We're adding 2 to it. So our answer should be 59. So the 20th spot should have a score of 59. Let's see, is that one of our answer choices up here? Let's say 154, that's not right. 67, no. There is a 59. Let's check it out. Let's see if that's our answer and if it'll send us to our next clue. Did okay, I got another location. All right, this looks like some painting of flowers. So let's see if we can find it to see what happens next.
Explosive teams head off to find your explosives. Epsilon, you should head over to Nexus Computing. When you hear the explosives, chaos will be ensuing. So grab the computer and get out. To find the location of the explosives, solve this problem.
Okay, take a picture of it. All right, let's see. It's giving us an equation. It says g of x equals 2x sine of x. And it wants us to find g prime of x. Okay, so this is a calculus problem. So that's the area of mathematics. All right, let's see. So I recognize this. This is actually 2 equations stuck together, and they're using multiplication. So we need to use the product rule. So let's write that down, product rule. So that means I need to break it up. So the 2 equations, it's 2x and sine of x. And I need to differentiate each of them. So let's see, 2x when you differentiate it is just 2. And then sine of x when you differentiate it is cosine of x. And so when we use the product rule, it's the first equation, so that 2x times the derivative of the second one, so 2x cosine of x, and then plus the second equation times the derivative of the first one, so 2 sine of x. So our answer should be 2x cosine of x plus 2 sine of x. All right, that's all our answer choices up here. Let's see if that's one of them. All right, let's see. We have negative 2 sine of x. That shouldn't be it. 2 cosine of x shouldn't be it. But we do have 2x cosine of x plus 2 sine of x. So let's see how this goes. Let's see if that is the answer. If it will give us the next problem. Okay, we have another location. It's a fish. All right, I think I remember that fish. I've seen it before. All right, I found the fish. Let's see the next clue.
Now that you have your explosives, you'll need to find the extraction point. I can't just tell you, where's the fun in that? So to learn where the extraction point is, you'll have to solve this problem. 100 people were asked if they eat meat, fish, both, or neither. You're told that 55 of them eat meat, 52 of them eat fish, and 21 eat neither fish nor meat. Given that a person eats meat, what is the probability that they also eat fish?
We know we want to know how many eat fish given that we know they already eat meat. So that's a conditional probability. So I am not interested in anybody who eats just fish or eats neither of these. So I can get rid of them. So that leaves me with just 55 people to choose from. Now of those you have to eat meat, so that's 28 of them. So that should be 28 out of 55. Let's see if that is one of our answers. It's 52 out of 55. 28 out of 52, 28 out of 100, neither of those are what I got. 28 out of 55. So let's see if that gets us our next clue.
Operatives. The data appears to be corrupted. When we used the last password you sent us, all we found was this map. We believe this shows the location of the extraction point. See if you can find this spot, and if there's anything of importance, add it. While you do that, we are sending other teams to the locations to stop the bombings. Please hurry.
All right, we need to try and get to this extraction point before the other teams so we can stop them. Anything around that might, oh, what's this? It says mission success. Let's see what it'll tell me.
Operatives, because of your hard work, we were able to get to all of the locations before the bombs went off. We were also able to apprehend almost all of their people. Unfortunately, Team Epsilon did manage to escape. However, they did not get the quantum computer. We cannot thank you enough for your help. Without you, there's no telling how much damage would have been done. You may be called back into action if we find the whereabouts of Team Epsilon, so stay tuned.
So it sounds like we're done. It sounds like we got to everything. They were able to stop the bombings from happening. Unfortunately, the Epsilon team got away, but maybe that just means that we have more missions in the future. I know headquarters is going to see my notebook, so I need to make sure all my problems are solved correctly before I turn it in. But otherwise, sounds like we were able to stop them in time.